Welcome back to the second video on Azure Function Security. Today we are talking about managed identities with Azure Key Vault, API key authentication with Azure API Management, and also we will cover a role-based access control. In part 1, we secured our function with Azure AD authentication, ensuring only authorized users could access it. But what about securing credentials, secrets, or connection strings inside the function? Hardcoding them is a bad practice, and even storing them in app environment settings exposes them to users with portal access. This is where managed identity come in. They allow our function to securely authenticate to other Azure services, such as Azure Key Vault, storage, databases, etc., without the need to store or manage credentials manually. Let's secure our secrets using Key Vault integration. First, if you don't have a Key Vault yet, you'll need to create one. Search for the Key Vault service in Azure, then click Create New Key Vault. After that, choose a resource group that matches your function app resource group and give it custom name. Let's call it Azure Function Key Vault example. Select the appropriate region in your Key Vault. In terms of networking, we wouldn't be applying any firewall rules for now, so leave everything else as default. Once your Key Vault is created, let's add a secret. To do this, make sure your user has the appropriate role assigned. Click on Access Control, then navigate to Role Assignments. Let's select Key Vault Administrator for full access to manage secrets. However, in a production environment, always aim to restrict access as much as possible. After that, click Review and create the assignment. Now, when permissions is set, navigate back to the resource. Click on Secrets in the left menu and create a new secret by naming it and assigning a value to it. You are all set now. Let's go back to our function app and navigate to Settings, Identity. Turn on a managed identity to grant our function access to Key Vault. Now, on the Key Vault side, we need to allow this function identity to access the resource. To do that, create a new permission to read Key Vault secrets and select the managed identity from the Azure function. Looks like we are all done with this part. Let's jump to VS Code and retrieve the value from Key Vault. To work with Key Vault and Azure Identity, we need to install two additional libraries: Azure Key Vault Secrets and Azure Identity. Next, we need to define our Key Vault name and secret name we want to retrieve. Copy this from the Azure portal. In our function logic, we authenticate using Azure default credentials, a class that automatically handles authentication. Then we attempt to retrieve our secret. And since we already configured our roles, everything should work correctly. Now let's run it. Start with launching the debugger locally. Copy the generated URL from your terminal and paste it into your browser. As you can see, our secret value has been successfully retrieved. This confirms that our function is now fully integrated with Azure Key Vault. By default, our function is open to anyone with an access token. But what if we want to restrict access to specific clients using an API key? In Azure Functions, we have two options to achieve this. Option 1. Using environment variables. We can store an API key in environment variables and compare it to the value passed in the query parameters or headers when the function is invoked. If the provided key is invalid, the function should return a 403 forbidden status. However, as soon as the correct API key is provided, access will be granted. In this example, I've used a local environment key, which differs from the one set in your Azure deployment settings. Keep that in mind, as local env is non-deployed to app settings. On the other hand, we have Azure API Management, APIM, which provides a more robust solution for handling API keys. It offers features such as key rotation, access control, rate limiting, analytics, and more. With APIM, you can certainly manage your API's security and lifecycle. Go to the Azure portal and create an Azure API Management instance. Enter the name of the resource, organization name, and email address. For now, we'll select the development pricing tier. In this example, we wouldn't need to change any other settings. Simply click Accept and Create. Next, go to Policy Fragments. This is where custom restriction can be configured. Using this feature, we can check query parameters and validate requests. We'll explore the service in more detail in next videos. Finally, let's talk about Role-Based Access Control, RBAC, in Azure. As you saw earlier, I created the Key Vault administrator role and assigned it to my user. RBAC allows you to control who can do what within your Azure resources, whether it's a Key Vault, an Azure function, or any other service. Instead of assigning permissions to individual users, you can create a user group and grant permissions to the entire group. For example, you can give a group specific permissions on a Key Vault. Similarly, you can assign a group or a specific user as a contributor to a resource group. This means that all members of the group will automatically inherit access to all services within that group. Also, Azure gives us the possibility to create a custom role and assign different kinds of default permissions to it. And after creation, this role starts to be accessible within all resources in current resource group. And with that, we are wrapping up this video. Stay tuned, hit the like button, and subscribe to our channel for more content. See you next time!